Hello everyone, welcome to Physics Academy, and this is our lecture number 5 of Solid State Physics BSc semester 5. Okay, and in this class, we are deal with another very important concept, uh, X-ray diffractions. What is X-ray diffractions and this X-ray diffractions, importance of X-ray diffractions, and we study also the Bragg's law, which is related to X-ray diffractions of any kind of crystals and many things also. Okay, so let's start our class with my introductions. I am Mithun myself. This is Mithun Patra, and I am from NISER, SEPS, and SEPS means School of Earth and Planetary Science, and I am a planetary science researcher. Okay, okay. If anyone contact me or via mail, email mithunp09@gmail.com. Otherwise, you can contact with my number already mentioned in my description box. Okay, let's start our class. First is X-ray diffractions. So, what is the meaning of X-ray diffraction? First of all, we try to know what is X-ray diffractions. X-ray diffractions is means actually X-ray diffractions क्या है? X-ray diffractions is mostly used for the identifications of unknown crystalline materials. Okay, for identifying the unknown crystalline materials. तो एक अननोन क्रिस्टलाइन मटेरियल्स को फाइंड करने के लिए वी आर यूज एक्सरे डिफ्रैक्शन. देन characterizations of crystalline materials. Okay, next is the determine the unit cell dimensions. It's a very important. Determine the unit cell dimensions. Next point is determine the unit cell dimension and determine the crystal structures. So X-ray diffractions is basically used for those cases. Okay, X-ray diffractions are used for those cases. Yeah, that's fine. Now, next point is what is X-ray. Okay, what is X-ray? X-ray diffractions means क्या है, इसको हम लोग समझेंगे one by one. तो first of all, what is X-ray? X-ray is an electromagnetic wave. Okay, and this electromagnetic wave have a wavelength, a very short wavelength, approximately 0.1 angstrom to 1 angstrom. Okay, this is very short wavelength. And X-ray that as wavelength is very short, it means X-ray have very high energy electromagnetic wave, very high energetic electromagnetic wave. Energy electromagnetic wave, because we are all know E equals to h mu, and h mu equals to hc upon lambda. Lambda is less, then energy is very high. We are all know from these relations. Okay, so X-ray is a very short very low wavelength electromagnetic wave, and its energy is very high. Okay, that's fine. Next, we're trying to discuss diffractions. X-ray diffractions. Diffractions का मतलब सबको पता है. Diffractions means bending of X-ray around the corner of an obstacle. Okay, bending of X-ray around the corner of an obstacle. It means if we take an obstacle here, and this is electromagnetic wave. Okay, this is electromagnetic wave, and if we hit with this corner, and then this wave is bending. Okay, this case is called diffractions. This is called diffractions. And the same case is happened in the crystal structures, because crystal structures have a arrangement of atom in periodic manners. So when an X-ray incident on an atomic crystals, then X-ray is either diffracted or it will be passes through the crystals, So this is a big questions. Okay, so I just say about that. Crystals have a it's like a periodic arrangement of atoms. Okay, it's a periodic arrangement of atoms. It's like that. Periodic arrangement of atoms is like that. Okay, so if an electromagnetic wave electromagnetic wave, I mean X-ray, electromagnetic X-ray incident on it, then actually what happens? This electromagnetic wave passes through these crystals or it diffracted. I mean it's change its direction of path. That's a big questions, right? So we already know the conditions of diffractions. एक्चुअली डिफ्रैक्शंस के लिए क्या कंडीशंस होता है वो हम लोग को पता है, ठीक है। वो एक्चुअली क्या है उसके बारे में भी जानना जरूरी है। सो एज वी नो द डिफ्रैक्शंस विल बी हैपन, साइज ऑफ द ऑब्स्टिकल्स और अपर्चर्स should be comparable with the wavelength of X-ray. It means I just tell you this is an atom, okay, and this atom and with an X-ray is incident on it, okay, X-ray is incident on it. If this atom size is comparable with the wavelength of X-ray, okay, if the atom size is comparable, I mean equal or approximately equal to the wavelength of this wave, then this X-ray will diffract it. Otherwise this X-ray will pass through this atom. So this is the conditions of diffractions. So when as you know, the size of the atoms is always know this is 1 angstroms, approximately 1 angstroms. So that's why when X-ray incident on a crystals, a diffraction conditions will be satisfied, and then X-ray will be diffracted from this crystal plane. This is called X-ray diffractions. So X-ray diffraction is nothing but is the bending of X-ray from crystal planes, and this X-ray are bending from this crystal plane because the wavelength of X-ray and the size of the atom in the crystals are equal. Hence the conditions of diffractions will satisfy. Okay, and the conditions of diffractions will satisfy. This is called X-ray diffractions. Is it clear? Okay, that's fine. So X-ray diffractions is nothing but just write here what is the meaning of X-ray diffractions. क्या है actually X-ray diffractions? When an electromagnetic wave okay, wave incident on an atom, there is some touch, I have touched some, that's fine, rewrite again लिखना होगा, okay, sorry, just write here. Okay, X-ray diffractions actually क्या है? When an atom or an X-ray incident on atom of same size comparable to wavelength of X-ray, then diffraction conditions satisfy. Diffractions conditions satisfy. Satisfying and bending of X-rays occur, and bending of X-ray occurs. This is called XRD. This is called XRD. XRD means X-ray diffractions. So this is the definitions. I just clear here. What is the meaning of X-ray diffractions? Okay, this is the definitions of X-ray diffractions, and some discuss here some properties of X-ray and some properties of diffractions. Okay, yeah. Now just come to very important principle. This is called Bragg's law. What is Bragg's law? Bragg's law. So for deriving the Bragg's law, we just put a plane. I mean, just put a plane. I mean the atoms layers. Just draw a atoms layer. Just draw a atom layer this side. This is the one atom layer. This is the another atom layer, and this is another atom layer. Just it's all about atomic layer. Okay, this is looks like that. Okay, that's fine. Now consider an electromagnetic wave incident on this corresponding parallel plane. Electromagnetic waves are incident. Okay, this is electromagnetic wave incident on it, and then this electromagnetic wave diffracted. Okay, diffracted. We also consider another electromagnetic wave, I mean another X-ray incident on another plane, and this electromagnetic wave also diffracted along these directions. Okay, that's fine. Now, and this first this is the X-ray 1. This is the nothing but X-ray 1. This is X-ray 1, and this is X-ray 2. X-ray 2. X-ray 2 are incident on a crystal plane, and we consider this is the perpendicular on the plane. This is the perpendicular on the plane. Okay, that's fine. Now These electromagnetic waves are incident on the crystal plane with respect to crystal plane at an angle theta b. Okay. Similarly, this electromagnetic wave also incident on this crystal plane with respect to crystal planes is theta b. Okay, and then diffracted in directions with the same angle theta b, also theta b. Okay, that's fine. This is also the angle theta b. Okay, and as we all know, this is the distance between two crystal plane, and it is actually denoted by I put it here, interplanar spacing THKL. Okay, we just know about that, right? DHKL nothing but the interplanar spacings, and it is also interplanar spacing. This is distance between two plane. Okay. Okay, here actually theta b, I just write down all the parameters. Theta b is a Brack's angle. Okay, theta b is called Brack's angle. I mean, this is the angle between incident X-ray and surface of lattice. I mean plane of the crystals. Okay, surface of lattice or plane of the crystals. Okay, that's enough. And DHKL, already know about that. DHKL, this is the interplanar spacing. Interplanar spacings, we all know. Yeah, that's fine. Now let's take a perpendicular. Now let's draw a perpendicular. Now we draw a perpendicular. This is the perpendicular. Okay, we draw a perpendicular. Is clear? Okay. So now these angles are also those angles and these angles, I just mark here, this angle and these angles are also the theta b. You just imagine, this is your homework, how this angle is theta b. Okay, how easy angles is your theta b. Just push yourself and just try to calculate why these angles are also be theta b. Okay, these angles are also theta b. Just this is your homework part, how it is. This is just imagine and calculate. Okay, now from this now we just name the point. This is the point A, and this is the point O, and this is the point B, and this is the point C. Okay, so now from this triangle, now from triangle OAB H, now from triangle OABH sin theta B, sin theta B equals to okay, we just draw the triangle here. This is O, this is A, this is B, and this is the angle theta B. Okay, and this is the angle is 90 degree. We are all know. Oh, just put it. We just draw the pictures in very broad form. Yeah, that's enough. This is the angle 90 degree, and this is the angle theta B. This is O, this is A, this is B. So from sin theta B, AB, yeah, sin theta B, AB by OB, AB by OB. So at AB, this is equals to AB upon DHKL, right? DHKL. Okay, so now AB equals to DHKL sin theta B. This is equation number 1. Just clear? This is equation number 1. Next, in similarly, from this triangle, another triangle. Now from triangle OBC, yeah, OBC, sin theta B is equals to this is your part, this is 90 degree, and this is the angle theta B, OBC. Okay, so BC upon OB, right, and BC upon DHKL. So BC equals to DHKL sin theta B. This is equation number 2. Equation number 2. Okay, we get those two values AB and BC. So in all we are know the first difference in diffractions patterns. Path difference means what is the extra path actually this X-ray are taken. Okay, this X-ray 1, if just see X-ray 1 path and just see X-ray 2 path. X-ray 2 path is just take extra path AB plus BC. This is the extra path, and this is called path difference in X-ray diffractions patterns, right? So path difference. So path difference delta x equals to AB plus BC. So this is equals to DHKL. These two are same. So 2DHKL sine theta b. 2DHKL sine theta b. Okay, as we know, for conservative interference, or constructive, it's a very well known constructive interference. Constructive interference, path difference is equals to n lambda, where n is mainly 1, 2 or 3. N1 is first order, N2 is second order, and N3 is the fourth order, and so on. 1, 2 and 3, and so on. Okay, so that is equals to 2DHKL sine theta in lambda. Okay, so 2D sine theta b equals to in lambda. Here n is order of diffractions, please remember. Okay, yeah, n is the order of diffractions, order of diffractions. Okay, be careful, this is called Bragg's law. Okay, this is called Bragg's law. Bragg's law, just remember, this is called Bragg's law. Okay, so here theta b is Bragg's angle, and this angle is measured from the plane of the crystals. Be careful, this is the plane of the crystals, and this is the X-ray incident on it. Actually here angle is measured from this crystal of this plane. Be careful, this is the point here, and this is the plane of crystals. This is the plane of crystals. Be careful. Okay, this is the Bragg's law for crystal diffractions. Now we take Bragg's law in terms of angle of incidence. Okay, this is a very important point in your comparative exam purpose. This is a very important point. Okay, be careful about it. Bragg's law in terms of angle of incidence. Theta. Okay. So actually what can I what can I ask you? What ask you actually? This is a crystal plane, we all know, right? And here electromagnetic waves are incident and then diffracted, right? Diffracted. This is the electromagnetic waves and they are diffracted, and this is the incident on this plane, right? But we all are know this angle is called theta b. It's called Bragg's angle, but this angle is called theta. It is called incident angle. So if your question paper gives you Bragg's angle, then Bragg's law is different, and your questions mentions angle of incidence, then Bragg's law is also different. So be careful. So here one angle is measured from the plane of the crystals, another angle is measured from the normal of the plane, right? Normal of the plane. This is the difference here. So here actually theta b measured from plane of crystals and theta measured from normal of plane is 2. Very important. So which anyone is mentioned in your questions paper. So please be serious when you do any kind of problems using Bragg's law. Please first for a second just check which angle is actually mentioned here, Bragg's law, Bragg's angle, or angle of incidence. If Bragg's law is mentioned, then you can use the first Bragg's law equations, but if angle of incidence is mentioned here, then use another Bragg's law. Now develop it here. Okay. So from these expressions, from this pictorial form, we know theta b and theta is equals to 90 degree. Yeah, that's fine. So theta b is equals to 90 degree minus theta. So from this figure, okay, is clear. So now from Bragg's law, Bragg's law 2d HKL sin theta b equals to n lambda 2d. I just write here d. No matter, don't worry. Just d is the interplanar spacings. Okay. Sin 90 degree minus theta n lambda. So 2d 90 degree minus theta is equals to cos theta equals to n lambda. So please point this, get it point. So please get this point. Actually here we use, okay. So when Bragg's angle is mentioned, then Bragg's law is 2d sin theta equals to n lambda. But when angle of incident is mentioned, then Bragg's law is 2d cos theta is equals to n lambda. And this question is asked in your TIFR examinations. TIFR examinations. When you solve your TIFR questions paper, then you saw it. Okay. Okay, that's fine. Very good. Now we derive another equations. Now we derive another equations that is nothing but diffractions angles. Okay, nothing but diffractions angle. You just write down it. Okay. Next, take a heading. Next, take a heading. Relations between diffractions angle and Bragg's angle. Relations between diffractions angle and Bragg's angle. Okay, just take a note. These points are very important in your competitive exam purpose. Okay, so again we draw the crystal plane structures. These all are the crystals planes, and again you know the X-ray are incident on it, the plane, and then diffracted. Another X-ray also incident on another plane, then again diffracted it. And this is the normal of this plane, as you all know. And this is the angle of Bragg's angle, right? And this is also the same Bragg's angle. As what is the meaning of diffractions angle? Let us now know. Let's try to know what is the diffractions angle. Just to imagine, if this plane is not here, then what happen? Then this electromagnetic waves passes through the crystals, right? Passes through the crystals. But due to this plane, this X-ray will be change its path by some angle. This angle is called actually diffractions angle. This is called diffractions angle. Theta d. We are all know, right? So as we know, this is the angle of this is the angle theta b, and also this is the angle theta b. Both angles are theta b. this is the angle theta b, this is the angle theta b. So theta d is equals to theta b plus theta b, that is equals to 2 theta b, 2 theta b, right? 2 theta b. This is the angle 2 theta b. So theta b, theta d is equals to 2 theta b. The relations between Bragg's angle and diffraction's angle. Okay, so now we know Bragg's law is equals to 2d sine theta b equals to n lambda, and sine theta b equals to n lambda upon 2d, and theta b equals to sine inverse n lambda upon 2d. Okay, and theta b is equals to theta d upon 2, that is equals to sine inverse n lambda upon 2d, and theta d equals to 2 sine inverse n lambda upon 2d. Okay, so please remember this. Just please remember the way how can I derive the angle of diffraction's angle. Okay, this is called diffraction's angle. Yeah. Okay, that's a fine. That's a fine. Now take some brief idea about this expression and try to know what is the importance of Bragg's law. Okay, try to know about the importance of Bragg's law. Right, what is the importance of Bragg's law? Importance of Bragg's law. Importance of Bragg's law. As you know, Bragg's law is nothing but 2d sine theta, 2d sine theta b equals to n lambda. We just consider for first order. N equals to 1. Okay, 2d sine theta b equals to lambda sine theta b equals to lambda upon 2d. Okay, lambda upon 2d. So here lambda is constant for particular X-ray. Lambda is constant. So sine theta b is directly proportional to 1 upon d, or from these expressions, right? And also we know the interplanar spacing is equals to 1 upon for cubic crystals, that is equals to a h square plus k square plus L square. If we just put it here, sine theta b is proportional to inverse directly proportional to h square k square L square. So it gives the positions of okay. So what actually get from this expressions? What can I get expressions from this? Actually, from these expressions we gives the positions of peak. Positions of peak. Actually, positions of peak means we get the peak for a corresponding plane at some particular particular Bragg angle. Also, from these expressions we are also know about when the value of h, k and l are increased, then Bragg's angle is also increased, right? So here we take a note. That is very important. Note 1 is if HKL value is increased, then theta V view will be also increased. And second point is if we know the plane, if we know the plane, it means HKL value, then easily get some easily know about, then we know the positions of peak of the X-ray diffractions spectra. You know the positions of peak of XRD. Okay, so this is the very important, and this is the practical part. When you in your masters you doing some practical on XRD, then you know about all the things. What is the importance of this Bragg's law, and what is the I just highlight here. This is the importance. I just highlight here. Okay, I think you know all the points, and I can discuss in details about reciprocal, that is in next lectures, and just enjoy these lectures. Okay, thank you and keep learning. And मैं फिर से आपको बहुत लोगों को बोलूँगा, if anyone feel to some problems to understand the every concept, so put a message in our WhatsApp group. I just try to solve. Okay, via Google Meet or any kind of use two applications. Okay, so today's class are now finished here, and keep learning, and just focus on your goal, just focus on your upcoming examination, as well as focus on concept building part. Okay, that's good. Okay, thank you.